Okay, so we have completed discussion on STP, spanning tree protocol. So we discussed various aspect of STP. Where do we use this? Okay, so let's say if I have two switches with two different links, so the expected or the what we would see is we would see there will be some broadcast happening in a circular direction. Okay, if something is coming from a computer, so let's say a ethernet frame reached on this interface. So what switch does is switch is going to broadcast that to both the interface, and now both the cables are going to carry that ethernet frame. It's received here, and from this point it will push to the next computer, as well as it will push one copy to this interface. Now this ethernet frame will come back, it will again hit here, again this will be broadcasted. Okay, so what happens is there is circular looping happening here. So to avoid that we make use of STP. So STP is a layer 2 looping avoiding mechanism. We checked the default behavior of STP, like what are the different states of STPs. Okay, it starts from blocking, it goes to listening, learning, and forwarding. So from a blocking to forwarding, it usually take 50 second, 30 second over here, 15 second here. Okay, sorry, this is 20 second, 15 second, and 15 second. This is a predefined values. These cannot be manipulated. This is a default behavior of the legacy STP. It takes 50 seconds for a port. Let's say I have a new switch, I connected to the production environment. So as soon as I make as soon as I bring the switch, it will take 50 seconds on each one of them to undergo the state and start forwarding the datas. Okay, so what else did we see? We checked about the other factors of STP, like the BPDUs, the components within BPDUs. These are the port types: root port, designated port, blocking port. So we did simple uh, calculations. So I considered three switches, and we did the calculation which one would be blocking, which one would be forwarding, right? So I said let's consider this to be the lowest MAC address. Okay, so the first thing to calculate STP is your root bridge. The formula for root bridge is bridge ID equals to priority plus MAC address. So the lowest always wins. So when I did that, I got this to be the root bridge. Now second step here is to find the lowest path, or to find the lowest cost to reach the root bridge. So from this point of view, this becomes root port, and from this switch point of view, this becomes root port. So what is the definition for root port? The lowest cost to reach root bridge. Okay, now the last aspect was to find the blocking port. So we don't have to find anything here, because when we have a root bridge, its port are called as designated port, and the designated port are always in a forwarding state. Okay, so we have designated port, we have root port, we have designated port, and we have root port. Now we need to find out for this as well as this. So for blocking, it's again start with root cost first, or the cost to reach the root bridge. Okay, so let's say I have to find the root cost. So now it's equal. Let's say from this point of view, if it travels in this direction, it's 2 hops. Okay, let's say the cost was 4 and the cost was 4, so totally it is taking 8. Now from this switch point of view, if it goes in this direction, it's again same 4 and 4, so totally 8. Now that's a tie. I cannot go and decide which is forwarding and which is blocking. So the next criteria for tiebreaker is the sending. Okay, the sending switch must have the lowest bridge ID. Once again, the formula is same as this. So from this point of view, if I see the sending switch bridge ID, it's going to be priority plus the MAC address. From this point of view, if I check the bridge ID, it's going to be priority plus the switch 3 MAC address. Now which is slowest? Obviously this is slowest. So any packet which is traveling in this direction will be allowed. Now this becomes the designated port. Designated port are forwarding in nature, and this gets blocked. Okay, so this way we calculated STP. Now what is a drawback of STP? The biggest drawback of STP is that 50 second. Okay, each time, let's say in a normal scenario, if something goes down, for reconvergence or the recalculation, we call it as reconvergence. Okay, this will take at least 30 seconds. Reconvergence will take 30 seconds, and for any switch port from disabled mode to a forwarding mode will take 50 seconds. Now these are some huge timers which are equivalent to like 1 minute. 1 minute of downtime is also very critical in the network production. Okay, so we are going with the next flavor of STP, which is called as rapid spanning tree protocol. Okay, it's again an example for IEEE. That means we can use this in between a Cisco devices as well as any other multi-vendor devices. So let's see how STP is different than the legacy spanning tree protocol. Okay, so let me open up my presentation. Okay, so what is the benefit of rapid spanning tree protocol? Okay, but before that, let me show you the IEEE standard for this. So the IEEE standard is 802.1W. What was the earlier IEEE standard? It was 802.1D. This is .1W. So you have to remember this from your exam certification point of view, because you are getting the optional answer type question. So they can ask you what is the IEEE standard for rapid spanning tree, and they might give you 4 answers. Now you have to pick the right one. Agree? Now if you don't know, then you will probably make a mistake on this simple question. So this also is important when you are preparing for the certification. Okay, so that's 802.1. So what is the benefit of rapid spanning tree protocol is it's going to give us 3 important features. These 3 important features are actually Cisco proprietary. Okay, in the sense there is something called PVST, which is not in the CCNP syllabus, which is seen between the only Cisco devices. So when Cisco was working on this spanning tree, per VLAN spanning tree protocol, it announced some benefit of this spanning tree protocol. Okay, your legacy spanning tree don't have this benefit. Your spanning tree doesn't have that benefit, but in rapid spanning tree protocol, these are inbuilt feature: port fast, uplink fast, and backbone fast. So I'll tell you what are each one of them and how are they making rapid spanning tree much more faster than your legacy spanning tree protocol. Okay, fine. So regarding the port states, in rapid spanning tree, it's discarding, learning, and forwarding. What was the case in your legacy? In your legacy, you had disabled, you had blocking, listening, learning, and then forwarding. Agree? But in the case of rapid spanning tree protocol, these three are now being taken down and discarding has been placed up. Okay, so discarding consists of three states of your legacy spanning tree, that is disable, blocking, and listening. So the three states contributes to one state in rapid spanning tree. Rest are same, learning and forwarding. But again, learning is not going to take 15 seconds for the transition from learning to forwarding. It's just in 1 second. Okay, so in 1 second of timer, these states get transited. Okay, so what was the timer in your legacy spanning tree? It took 50 seconds totally. But in case of rapid, from discarding to learning, learning to forwarding, it only takes 1 second. So that is a major advantage. Now I can say that learning is taking transition in milliseconds. Okay, in millisecond the transition happens to forwarding, so that is very much faster. It's not only about the speed during building phase. Okay, it's even in the later on when there is something called reconvergence. When there is a topology change, if a switch has been removed or a new switch has been plugged, there will be topology change, right? Even that thing is faster. Okay, in your normal STP, it used to take 15 second to 30 second for the new switches to adopt and recalculate, but in this case it's take just 1 second for your transition. So that is why rapid spanning tree is much more faster and it is industrial adopted. Nowadays, all enterprises will have RSTP running. Okay. What about the port roles? What about the port role in your older spanning tree? It used to be designated port, root port, and blocking port. Okay. In this rapid spanning tree, we have two additional port states. So your root port remains the same, designated port remains the same. Both are forwarding in nature. This is forwarding in nature and this is also forwarding in nature. Now we have alternate port and backbone port. Okay, so these two are blocking in nature, but they are useful for us to achieve uplink fast and backbone fast. Now what is uplink fast and what is backbone fast? So let me tell you. Let's say I have a switch, three switches kept in this topology. Okay, so let's assume this is the lowest MAC address, this is the second highest, and this is the highest one. Let's say the blocking was happening on this. Okay, so this is designated port, this is designated port, this becomes the root port, and this is root port, and this is designated port. Okay, so the blocking is happening across on this. When you change from your STP, when you change or when you migrate your networks from STP to rapid spanning tree protocol, now this will be not blocking. We will call this, I mean, we will, it will be blocking in nature, but we will call it as alternate blocking. Okay, just from the plain blocking, it will transit to alternate blocking. That is this behavior. Now what is the advantage of having alternate blocking? Now let's say the direct link. Okay, the direct link for some reason goes down, one fine reason. Okay, this will just take 1 second to reconvergence and to start becoming root port. So that is the advantage. We are not going to keep it under blocking state like we kept in the legacy spanning tree. The reason is, if it is in a blocking state, then it will go through that 50-second of transition period from blocking to listening, listening to learning, learning to forwarding. In case of rapid spanning tree, we are keeping it under a special mode which is called as alternate port. So what is the advantage of keeping alternate port is, in case of any direct link failover or failure, this alternate blocking port will immediately become root port in a forwarding status, and it will take only 1 second for that. So that is the advantage, and that is why we have introduced a special port called as alternate port, and it's called as uplink fast. Uplink fast is nothing but, as soon as something goes failed, this alternate port is promoted, okay, promoted to reach the root bridge. Now directly you can reach the root bridge. So if something was down, immediately there is a path allowed, okay. So in this case, what happens? So let me tell you what happened in this case. So I'll redraw these three switches. Let's say this was root port, this was root port, this was blocking. As soon as this went down, switch lose its path to reach root bridge. Agree? Now switch only has this path to reach root bridge. And in my legacy method of STP, it was taking 50 seconds, equivalents to 1 minute. Now that is a drawback. Now that is why I got a RSTP. Now this will be in a alternate blocking state. It will just take 1 second to convert to the forwarding nature. Now even though this is down, your switch can still reach to the root bridge. That is a behavior of a alternate port. Now what is a behavior of a backup port? Okay, why do I need backup port? So let me take one more scenario where I can explain you. Okay, I'll take something else which I can show you properly. Okay. So let's say I have this network topology. These are the three switches, switch number 1, 2 and 3. And as we know, this was alternate blocking. This is a plus point of your RSTP. In a legacy, the same AP is just a blocking behavior which will take 50 seconds. But in RSTP, blocking is now alternative port which is blocking in nature. As soon as something goes down, this will immediately convert to root port and it will start forwarding. So this switch can still reach here. So we are good with alternative port. Now what is backup port? Okay. So that is an scenario when my manageable switch is connected to a hub and the hub is connected to some computers. So let's say this hub, which is also known as unmanageable switch. Okay. So let's say I have the same VLAN added up, VLAN 1, and I have VLAN 1 added up, because by default we cannot give any other VLANs to a hub. What do you understand by hub, by the way? So hub is an unmanageable switches. So that means you give some input. Let's say you are giving VLAN 1 as an input. So this hub device will give the output on the same VLAN. So all of them will be on VLAN 1. Okay. This is a unmanaged device. We also call it as a non-brain devices, or we call it as a dummy boxes. You give some input. Let's say you are giving VLAN 10 and you will expect all of them giving the output in VLAN 10. Okay. So they don't have any software. They don't have some iOS software within them which we can upgrade. When you purchase these unmanaged devices from market, they will be installed with some software, and that is the software which will do the work. Okay. So these are non-brain devices. You give some input, you can take multiple outputs on the same VLANs. Okay. Wherever your manageable switches, like these switches, they are called manageable switches, smart devices. So you can give multiple inputs. You can give input of 10, you can give input of 1, you can give input of 20, as well as you can take the input in different ways. Like you want 10, you can configure. You want 20, you can take that. You want, so these are more smarter, manageable devices. These are the devices which we use in the access layer, core layer, distribution layer. Now, where do we use hub? Hub is used on a desk. Let's say I have one computer. Along with my computer, I have some printer, I have some IP phones. Okay. Now, this is a scenario when I would connect one hub, and hub will connect to all these three devices, because hub are very uh, reasonable pricing. Might be for $50 or might be for $20. You will get a hub which you can keep on your desk in case you have multiple devices to be connected to network. Like might be you have your own printer or you have your own IP scanner machine, right? So for that you will not spend $500 of a managed switch, because all of them at the end it's about just taking the same output, all in the same network. Okay, so that's difference between hub and a switch. Now in this scenario, let's say this was a desk, some employee's desk, okay, where he have some computer. Let's say he have some IP phones, he have some other IP capable devices. So from this switch, we have two inputs given to the hub. Now both of them will be on the same VLAN, because I told you this hub will not have any different VLANs. Whatever you give, you will just take it up. You might give two different inputs, but both of them will be on a same VLAN or on a same broadcast domain. Okay, so for a hub, it always fall under single broadcast domain. It will always fall, or it will always work on a single VLAN. VLAN 1, then everything will be on VLAN 1. If it's VLAN 10, then it will be on VLAN 10, but only one single VLAN. So we call hub as a single broadcast domain. So in this case, both are working on the same VLAN. Now you will also receive VLAN 1 here, VLAN 1 here, VLAN 1 here. So that is all good. Now there are two links. Now the STP has to be calculated. Now the same process that we followed in the yesterday's class about finding out the equal or the lowest cost. Now in this case, they both are connecting to the same switch. So that is a tiebreaker. Second one is sender's bridge ID. Now in this case, they are connected to the same switch. So that is also a tie. The third one is sender switch physical interfaces. So in this case, let's say this is 0/1 and this is 0/0. Now this will win the election because of being lowest one, and then it will be designated port, and this will be taken up the backup port. Okay. Now what is the why do we need backup port? Let's say this went down, so the backup port will now be the designated port with the forwarding nature. Okay, so these two ports are a new concept introduced in a rapid spanning tree protocol, and they both are introduced from the reconvergence point of view. Where is AP coming up? AP is coming up in the core switches, inter switches. If the normal connection goes down, whatever was blocking, which was designated as AP, will now become the root port, and it will start forwarding. It will take only 1 second to do the transition. Where is this coming up? This is coming up in a picture when a switch, okay, let's say I have one switch. The switch has two links connecting to another hub in the network. Now these two, one will become designated and one will be called as a backup port. Okay, and this backup port will also take just 1 second in case of this going down. So these are the two addition of features. Okay, that is why I mentioned in the very beginning of RSTP that it has additional features here. This is alternate port and this is backup port. The alternate port is also called as uplink fast, which directly deals with root bridge connection, and backup port deals with your scenario when a switch is connecting with another switch on a two links. Okay, so instead of one making as a blocking, we would rather make this as a backup port. Okay, fine. We will do this on lab and I'll show you how it works over on practical as well. So something which we discussed is port role. Okay, and on this diagram, the diagram which I have here, so this is my root bridge. Root bridge will have designated port. Designated ports are always in forwarding in nature. Okay, we have two directly connected switches, let's say 2 and 3. So this will be root port and this will be root port. Root port are also forwarding in nature. Now the calculation has to be happen between this. Okay, so since there is no so since let's say this and via this, we would prefer this way because of the lowest path cost. Okay, so this takes up the root this takes up designated port and this takes the root port. Similar way, when we talk about this landscape, now there is the backbone fast concept coming in. I told you, when I have two switches and the two switches has two uplinks. Okay, one has to be backup port and one will be your designated port. So in this case, this one is designated port and this one is in your backup port, which is blocking in nature. Okay, the designated port will be in forwarding, so your data is going in this direction. It's going in this direction and this is in your backup blocking nature. As soon as this goes down, it will just take 1 second for your RSTP to reconvergence and start taking the packet from this. So this is an advantage of RSTP. Okay, we don't put them in blocking. We what we do is we put them in some special state. Okay, like alternative port or backup port. Now they do the work of blocking, but a temporary blocking. As soon as requirement is to reconvergence, it will take just 1 second for reconvergence. Okay, so let's see how RSTP is calculated or how RSTP works. Okay, in my previous scenario, when I was discussing about the normal STP behavior, we saw the behavior over on Wireshark. Okay, so what happens was the BPDU is being transmitted. The BPDU will be flooded across the switches. Okay, so this switch is sending the BPDU in this direction as well as in this direction. This switch will also send the BPDU in this and as well as this direction and similar way. And then they will, what is the BPDU going to carry? It is going to carry the bridge ID, which consists of priority plus MAC address, and that is how they will decide who is going to become root bridge. Once root bridge is elected, now they will see what is root port. Okay, who is going to be the root port. Now let's say this becomes root port, this becomes root port, and then they will find out the blocking nature. Now in case of rapid spanning tree protocol, it's not about your BPDU or the configuration BPDU. It's more simple. Okay, you will see two types of negotiation here. It's called as proposal and agreement. Okay, two types of negotiation happening. So let's talk about from switch A and switch point of view. So switch A is going to send some proposal. Okay, and switch B also is going to send parallelly some proposal. Now what is this proposal going to carry? They are going to carry the bridge ID of their own. Okay, so this switch A is going to carry the bridge ID of its own with the priority and of course the MAC address, and it's going to say that I am the root bridge. It's going to say I am the root bridge. Similar way, switch 2 is also going to carry its own proposal with the bridge ID. Now both will be checked upon, and which one would win the root bridge election? The one with the lowest bridge ID will win the election. So let's say this has the lowest bridge ID. So this is becoming root bridge, and now this will see the root port. Now this becomes the root port. Okay, this becomes designated port, this becomes root port. Similar way, switch B and switch C also will work on the proposal. Okay, switch B now will send the detailed of switch A, because the negotiation has happened between switch A and switch B. Switch B knows that this is a root ID. Okay, switch B knows that this is a root bridge, and we know that inside spanning tree protocol there are two fields. One is for root ID, second one is bridge ID. Okay, now between B and C, what switch B is going to do is it's going to send the root ID. Now root ID is nothing but detailed of switch A, because switch B already knows that there is some superior switch than me, so there is no point sending my details to switch C, right? Let me send the superior switch detail. So in this case, it's going to send the root ID of switch A. So switch A root ID will be sent to switch C. Switch C will send, of course, its own, because it doesn't have interacted with any other switches. So the negotiation will happen, and let's take in this way that switch A is still superior. Okay, superior in the sense it's the lowest among all the three. Now switch C also will come to know that the root ID will be switch A and then its own. Okay, so rapid spanning tree happen on a segment basis. It happen on every segment, whereas your STP was like a tree. Once I have the root bridge elected, then I will only make sure how to reach the root bridge. Okay, now let's say in my legacy spanning tree, this is root bridge. Now every switch will make sure how to reach root bridge, whereas in rapid spanning tree, it's between the segment. One RSTP proposal will happen here, the second RSTP proposal will happen here. So how do RSTP negotiate? Over on two negotiation, that is proposal and agreement. Okay, now where is agreement? We have not discussed about agreement. Now let's say in the first scenario, when both shared their own proposal, switch B says that okay, I am fine, I see you are superior than me, so switch B has to agree for that, and that is sent via agreement packet or agreement broadcast. Okay, similar way between switch B and switch C, when they started up with the proposal, one has to agree to the second person. Yes, I agree that you have the superior bridge ID, so I am going to send it. So it's basically going to notify with the help of agreement packet. So that is how these two comes into picture. Okay, to make it more easier, I think I have one more scenario. The scenario is when I have three switches. Okay, so when I have three switches, let's say these are sending the proposals. Okay, I thought there was some voice lag because I got some latency. Okay, fine. So in case of this scenario, they are having the proposals. Okay, all the three segment are having the parallel or simultaneous proposal. This will send the proposal, this will share its own proposal. So what is the the content of this proposal? So basically it's the bridge ID, the bridge ID of their own. Okay, so this will send the proposal containing its own bridge ID, this will send the bridge ID of its own. Similar way the proposal is happening here, and so and so. And once they get decided, they are going to send the agreement saying yes, I am fine with this, and then it just take one second for this transition, and then they know which is designated, which is root port, which is again designated, which is alternative port. Okay, it just take 1 second. It is not going to take 50 seconds for your listening, learning, all those things. It's very simple in case of RSTP. It will follow with the discarding state. It will directly go to the learning state, and from learning it will go to the forwarding state. Okay, so your legacy has three other things here, like disabled, blocking, and listening. Now these three is just a part of discarding. So discarding to learning, learning to forwarding. Just 1 second for your complete negotiation. Root bridge will be elected, root port will be elected, and a alternative port will be elected. Now this is something called as uplink fast. Okay, so what is the behavior of uplink fast? It's in a blocking state. Okay, it's in a blocking state, but it's in a temporary blocking state. As soon as the requirement is, let's say this goes down and this has to come up, or a reconvergence happens, it takes just 1 second for this to get converted to root port. Okay, it will not go back to the legacy kind of negotiation from every step by step. Okay, so that is the plus point of keeping it under alternative blocking. Okay, now regarding the backup uh, feature, the second concept of backbone fast. So what is backbone for fast? What is the condition to achieve this? So when I have the switches and in between I have a hub. Okay, always remember, hub work on a single broadcast domain. What does single broadcast domain say? Or what is a domain, by the way? Let's say I have VLAN 1. Now this is one broadcast domain. Okay, if I have even 100 computers which are working on VLAN 1, I can say they are part of one broadcast domain. Okay, now let's say I have two VLANs, VLAN 1 and VLAN 2. Now they are equivalent to two broadcast domains. Okay, the switch is working on two broadcast domains. Similar way, if I have 100 VLANs, now each VLAN is a part of its own broadcast domain. Let's say 1 is its own broadcast domain, 2 is its own broadcast domain, VLAN 3 will fall under its own broadcast domain. So we will have 100 broadcast domain. Okay. Similar way, in this case, since I am making use of a hub fall under only one broadcast domain, because the working nature of hub is little straightforward. You give input, you just take that output. Okay, you, no matter what input you give, let's say you are giving 1 as a input, you are going to take 1 as a output. Let's say you are giving 21 as an input, you are going to expect 21 as an output. So they are always in one single broadcast. Now no matter you connect 2 links, 4 links, 5 links, they all will be part of one VLAN. Okay, it can be 1, it can be 10, it can be 20, it can be anything, but it should be a single VLAN. Let's say they are VLAN number 21, so all are going to be VLAN number 21, and on the outside you are going to take the VLAN 21 itself. Okay, so in this kind of scenario, what happens is you have 2 links and you have 1 hub. Okay, so the normal calculations happens here. When you have this one, they are single broadcast domain. We need to see the tiebreakers, and depending upon the last criteria of sender switch lowest physical IP number, this link win the election. Okay, so 016 is considered to be designated forwarding when compared with this one. This is 017, so this will win the election. Okay, so now when you have 017 and 017 left out, in case of RSTP, you have this new concept of backup fast. Okay, so now what happens is this one will be elected as backup bone fast. The same criteria what we followed up to find out designated and blocking, the same calculation or the same concept will apply here. This will become as a backbone fast and this will become as a blocking. Now this is an scenario when, let's say, this link goes down. It will take only 1 second for this link to get into forwarding. Okay, so this is a behavior of your RSTP. Okay, and this I have already discussed. When we have 2 uplinks to a hub, one becomes backbone fast and one becomes designated port. Okay, now regarding some terms, okay, it's called as port types. So if you guys remember, let me show you by taking one of the devices. Okay, so let me quickly see the output for show spanning tree. So when I see this show spanning tree, it's still running on legacy spanning tree protocol. No changes. There is nothing what I'm trying to show here. The concept that I want to show you is this. So yesterday someone was asking what does this P2P refers to. Okay. So this is called as point to point. And we normally see this between two switches. When my STP is getting calculated between two switches, okay, now they will share some interface settings. Let's say both of them are working on duplex or on full duplex in the sense they can send the data as well as they can receive the data at the same time. These are part of mode of communication. Okay, we have uh, half duplex, one is simplex. Okay, okay, 1 second. So there are three modes of communication. One is called simplex, half duplex, and full duplex. Okay. Simplex is when you're sending just in one direction, when the traffic is going in one direction. Half duplex is an scenario when you're sending traffic or data in one direction. Once this data has been transmitted, then you will initiate the traffic in other direction. So it is one way communication always. You're sending first, you are waiting it to get over, and then you are going to receive something. Full is a scenario when you can send and you can receive at the same time. Okay, so these are the mode of communication, and depending upon the switch port configurations, okay, the switch port configuration we can change. So all your hub which we just discussed, they work on half duplex. All your intelligent switches, they work on full duplex. Okay, so in the case of two intelligent switches, when they have the full duplex setting, when they can send and receive, they form a point to point connection. Okay, now if I change this settings to half duplex, just take an example. Now this will also get changed to shared medium. Okay, that is why you will see sometime it you as a shared connection, shared type. Okay, now that is an example when I have half duplex on one side and I have full duplex on one side. So you will see P2P, you will see SHR, and you will also see something called as edge. Okay, now edge is an scenario when you have a switch connecting with a computer or a non BPDU devices. Now in this case, this will be represented as a edge. Okay, so this is something which I'm going to discuss. So I just showed you this console, okay, to help you with the with that. So what is edge port? It's a port where the switch connects with one of the what do you say, one of the end devices. Okay, you have root port and you have point to point. As I told you, point to point is full duplex connection. When you have two switches working on full duplex, they will have P2P. If I change this behavior to half duplex, now P2P also will get converted to shade medium. Okay, because they are getting shade. Your half duplex and full duplex are not going to send and receive at the same time. So what happens is you're sending something. Once it's been successfully sent, then you're going to receive something. Now that is a shared medium. Okay, so these are some port types in rapid spanning tree protocol. I will show you during the practical. When I do the practical, I can show you what are edge port, what is root port, and what is point to point. Okay, now the basic difference between RSTP versus STP. So in your normal STP, BPDUs are originated by root bridges. That means if I have a root bridge elected, when I have a root bridge elected, so root bridge is going to send the BPDU, and that BPDU will be then sent to everyone. It forms a tree structure. If you just go back to very few first slides. Okay, I think I have not added up. So basically, it forms a tree structure. Your normal legacy STP behaves like a tree structure. Okay, one who is root bridge will send the BPDU to all other switches. But in case of rapid spanning tree, it's between the segments. It's not between the root bridges and the following switches. It's between the segments. So let me say I have the same network diagram. Okay, now this will be running the proposal, this will be running the RSTP proposals, this will have their own RSTP proposal, and same as this, and same as these and this. Okay, so that is what I said. In RSTP, each switch will originate the BPDU. So every switch is going to originate their BPDU. They will see who is superior, and then accordingly they will pass on the information. In the case of timers, the legacy STP has BPDU, the hello BPDU sent every 2 seconds, and the max timer is 20 seconds. Whereas in RSTP, it is 2 seconds. It's same for BPDU hello messages, and dead is 6 seconds. If for 6 seconds the devices don't respond, let's say I have two devices. If one goes failed, so it is going to wait only 6 seconds and the reconvergence will happen. Okay, it's not going to wait for 20 seconds. Regarding the cost, I have written the short mode of STP and RSTP cost. Okay, so these are all the cost with respect to the Ethernet technology, and then we have the default values. Okay, so this is something which we see in the RSTP cost values. Okay, what else do we have? And rest of the things are very same as your legacy. In case you want to modify something, or you want to manipulate the switch behavior, like we did in yesterday's or in the last class practical. Okay, so let's say this one took the root bridge election. Now I wanted this to be primary and this to be secondary. So the same commands apply. Okay, we can go with this two commands, and we can set it up primary and secondary. Regarding the path cost, that is manipulating the path cost value, that is also very similar. Let's say I have two switches. Okay, now this is a root bridge and this is some normal switch. Okay, when I have two links between this, one will be forwarding and second one will be blocking. Now let's say there is some SFP problem. Okay, let's say there is a problem with the cable, or there is a problem with the SFP. Now you have to manipulate so that this becomes forwarding and this becomes blocking. So two ways we can do that. One is by changing the path cost. Okay, I will go to the interface of this interface gi0/2 and I'll reduce the cost, whatever cost is running. Let's say this is running on 4, so I'll make it 2 so that this one will start forwarding and this will take blocking. Now let's say there was one more way that we discussed at the end of the lab yesterday, that is by changing the priority. Okay, so by default these have the priority of 128. Now if I go to the interface FA0/3, if I go to spanning tree port priority, I can change the priority to like 32. Now again this will start preferring and this will be put into the blocking state. Okay, this is in the case when we want to play around with the path. Okay, the primary and secondary or the priority, this comes when we want to play around with the boxes. When I have 4 boxes and I want to play around with these boxes, I want to make this as a root bridge, not anyone else. In that case, I will go with this command. Now it's between the two paths, then I can go with the cost and I can or else I can go with the priority, the interface priority. I said or, okay, it's not and. You can go with either of one. Either you can go with the cost or you can go with the priority and you can just change the default behavior. Okay, so that is same as your legacy boxes, no changes. The CLI command to change from your legacy 802.1d to rapid spanning tree is just a single command. If you go to the global configuration, if you put this CLI command, your devices will start running on rapid spanning tree protocol. Okay, and this is what you will see. And as I told you, shared is an scenario when one device is running on full duplex and other one is working on half duplex. You will get shared. Now if I change this half to full, now they will be P2P types. Okay, all will be getting converted to P2P. Okay, modifying the STP cost, we know we can change that. Okay, yes. These are some enhancement which we need to know. Okay, enhancement in the sense like let's say I know about STP, I know about RSTP, we are good. Okay, so between the switches we have these spanning tree running, either STP or RSTP. Now what about the switch port that connects to your computer? Do you need spanning tree here? Do you need any sorts of spanning tree between a switch and a computer? No. The reason is your computer don't understand what is BPDU. They are non-BPDU devices. Okay, it's only your switches which knows what is BPDU, and it's the loop. It get created only between the BPDU devices. Okay, when I have BPDU devices and I have BPDU device here, then there is a chances of becoming a looping. But in this case, I don't want any. I don't see any looping happening. Okay, so the best option would be I enhance these switch ports. Okay, I keep some special tuning on especially these switch ports. So topics like RootGuard, port fast. Okay, along with this we have BPDUGaurd, BPDUFilter, and also LoopGuard. So these are some STP enhancement or STP manipulating or tuning topics. Okay, so that is why I have listed them under STP topology or tuning or enhancement. This is seen in the case of a case when we have a switch to a computer. Okay, so in this case I can configure these STP. So basically what happens is we can start forwarding the interface, or the way this works will be irrespective of STP. There will be no elections. They have to not go under through any port states. Okay, so it's all enhancement topic. So we will do a lab and I will tell you what each one of them does. Okay, one simple question is why, just to say that why do we need those enhancement. Let's say I have this network topology with 4 switches. Okay, let's say I'm having STP. Now let's say I also have a computer. Now we know that STP take 50 seconds, but I don't want 50 seconds. I want it much faster. So what I'm going to do is, on this switch port, I'm going to configure the feature called port fast. Now what port fast does is, it will reduce from 50 seconds to only 15 seconds. Okay, so now this port will not go through 50 second. It will only go through the 15 second, because you have enabled some extra feature. Now what does this feature does is, your blocking, listening is not checked upon. It will straight away go to the learning. From learning, it will go to the forwarding. Now what happens is, there is no election happening here in this segment. Okay, when you have the port fast configured, there is no kind of port states happening here. It will straight away go from learning to forwarding. Okay, the issue is when someone in the field engineer take down this computer and he connects a computer. Okay, he plugs a cable between this switch to this port. Now this is a BPDU sending devices, and this is also BPDU sending devices, and we know that we have configured port fast, so there is no election happening. It directly went from learning to forwarding, and similar thing happen here. It will also go from learning to forwarding. Now both are in forwarding nature. Okay, now what happens is, there is a possibility of getting loop here. That is why what we do is, we just don't configure port fast. Along with port fast, we also add some extra or add-ons feature. Add-on feature like BPDUGaurd or BPDUFilter. Now what these add-on feature does is, in case of such mess, when someone took down the computer and connected a switch, when the BPDU was taken down, as soon as the BPDU reaches over here, this port which has this add-on feature is going to put the switch port under shutdown mode, or in the inconsistency mode. Now in this condition, this is equivalent to non-functional feature of the switch port. Okay, this is not going to serve any BPDU to any other devices. These are some special add-on features when we have to take care along with the port fast feature. You know what is port fast? When I have a computer to a PC, in order to reduce the 50 second to some 15 second or something, I will go with this. But what if someone from the field engineer side, who by mistakenly take down that computer and plugs a switch which is also a BPDU sender, right? Now two BPDU sender, and there is no STP calculation happening because of the port fast feature. Okay, now there is a loop happening, or there can be loop. Okay, is it only about the loop? It's not always about the loop. It's about the port security also. Okay, so let me tell you how the port security. So let's say these are the 4 switches which is running STP. I have a computer. Okay, so I decide to make this into port fast. So as soon as I make them into port fast, there will be no STP running, no STP. Now from the field engineer point, let's say some infected switch, or someone who is trying to cause some impact introduce another switch. Okay, he just introduced one more switch, and let's say the BPDU is better here. It has a superior BPDU. So as soon as the BPD will be sent here, the switch will send it to all other people. All other switches are going to do the same. Let's say this was initially the root bridge. Now the election will happen and then this one will become a root bridge. Now this is causing a huge impact, okay? Because we do not know who is connected to the switch. Let's say there could be a computer and this computer is being operated by some hacker or someone called as man in middle. Okay, so these are the circumstances that happens if you don't take care. Okay, if you just enable port fast will help you in reducing the time, but yes, in future it can lead to some complications. Okay, so along with port fast, I also have to make use of some extra add-ons like BPDUFilter, BPDUGuards. Okay. Now what happens when you have this add-on? As soon as you get something from some switch, some BPDU has been received here, this switch port is going to automatically shut down. Okay. So there is no way that something is being taken to the upstream switches because this is shut down. Okay. It will either go to shutdown or it will either go to the inconsistency mode. So this will as good as non-functional now. Now it will keep on monitoring. It will keep on monitoring to see that whether this has been taken down or not. Now let's say this was a mistake by the field engineer and he has taken down after 10 minutes and there is no BPDU being received. Now this will automatically fall back to the forwarding feature. Okay, it will automatically fall back to forwarding and then the normal behavior of port fast. It will see there is a no BPDU devices seen here and so and so. Okay, so that is why we take some extra extra steps when we go ahead with the port fast. Okay, so those are all documented under these slides. So RootGuard, port fast, BPDU guards, BPDU filters, and yes, so that ends your topic. And I have given all the command reference, whatever command that we used here, along with the debugs. And yes, there are some quiz. Okay, in case you want to practice after the class, so you can go ahead. You can try yourself solving something. Okay. So any doubts so far? Because I'm going to start up with the lab now. So do you have any doubts?
The table, okay.
Sorry, I didn't get you.
That table that you have just closed now.
You want to get the PDF back?
No, that table that you were.
You mean to say the command table? I didn't understand. Sorry.
The cost.
Are you talking about this?
No, the one that was showing the cost 4 for 10, 20 gig, like that.
This one?
That was the last table that you closed. No, I don't know. It is okay. No, let's continue. I'll find. Yeah, this one.
Okay. So you mean to say the cost table?
Yeah. I'm trying to compare to, because you're saying this is STP cost.
Yeah.
It's 4 meg to 10 100. Oh no. Okay. No, it's okay.
Okay, great. So are you planning to share any experience or something that you encountered on your daily premises or something?
Sagara have it.
Okay.
Okay.
How do I, Sagar?
Yes.
I have a question for you. So how do I, enable full duplex globally in Switch? So I know that is going to be globally for all ports.
Can we do that first of all on all? I think it's on interfaces basis, right? Let me try.
You mean the range command? I need to use the range command for
Yeah,
that,
you
or
you can
is
you
it?
can you can make use of range command for that, of course. But yeah, it's I don't think it's a global command. It's all
We don't have any for that.
yeah,
Okay.
it's a interface basis command.
Because I'm asking, we know in some devices has fast Ethernet, some devices has gigabit,
Okay.
so that's different,
No,
So we connect
when you have
gigabit Ethernet.
yeah, when you have Nexus, in Nexus you can configure on globally. You can change the settings of MTU, duplex, and all in a globally way, and that globally command will override all the interface. But in case of Catalyst boxes, the low end devices, it's only one technology on one boxes. If they are running Giga, they will run Giga. If it's Ethernet, it will run Ethernet. And I think it's only interface now. Okay, so I don't see any
Oh,
global command to change for duplex. Yes, it happens on a higher end devices, like you said. That is in the case of Nexus devices, where you can see Ethernet, fast Ethernet, Giga Ethernet. So you will have the global way to configure the MTU size or duplex. Okay, so in case of Nexus, you can do that, but in case of these lower end, it's interface basis only.
I have another one question.
Okay.
So if, for example, two switches, I have one gig Ethernet, another one is fast Ethernet. If I connecting to fast Ethernet to gig Ethernet, is there any problem with that full duplex and half duplex? Any speed issues will come?
No, it is not. It's not about any issues here. Okay, it's only about the type that I wanted to show you. So
So you mean the fast Ethernet and gig Ethernet should be okay if I connected both gig Ethernet
yeah,
and
yeah,
to the another switch?
yeah, yeah. It will be okay, because it is nowhere said that spanning tree will not work across half duplex, right? Only the type of port will get changed,
Okay.
and also the speed cost will get changed. Okay.
Okay. I see.
Sagar, I have a question. Like,
Yeah.
as you mentioned, between the two switches, if I connect any hub device to the switch, okay, those will be in same VLAN, and there we will get a backup port and backup port.
Okay.
Oh, but if I between the two managed switches, if I configure those two ports in same VLAN, will that work by removing means like if we don't have any hub in place between two switches, but those two ports are in the same VLAN.
So you mean to say when you have two switches and two
Hmm.
links and you don't have hub?
Yes, yes. I have, but those two links will be in same VLAN.
Yeah. So what is the problem? It will work, right? You can
Hub means back.
work. You can keep VLAN one and you can keep VLAN one here, right?
Yes, yes. For the same backup port will be backup port and alternative port will
Okay.
be
In
different.
case of backup, you're saying. So in case of
Yes,
backup,
yes.
it's a scenario when you have hub. Okay.
Only when
Yeah.
only in the
Only.
place of hub
Yeah.
it will be
Only.
backup.
Yes.
Then
Only in the case of hub it is.
okay, even those two ports are in same VLAN, that won't backup won't be coming in this scenario. Only backup will come in only in hub, right?
Yes. Yes. Because the chances are looping is happening over here in this case. Okay, whereas in your normal behavior, when you have two links, it will block one of the connection, so there is no confusion here. The confusion arises when you have one hub here, and since they are all under one broadcast domain, so this is also possible. So that is why we have to keep one port under backup port.
Okay.
So that is a some special scenario when we have hub. When it's non-hub scenario, directly one will be put up into alternative. This would be alternative port. There was no need of backup port. It was straight away alternative port and blocking of one, and one would be forwarding. But when we have hub, your data can also come in this direction, right? So instead of this, it can also come in this direction because they are in the same broadcast domain.
Thank you.
Okay.
Sagar Satish here.
Okay.
So in the diagram you're showing like hub is connected with the two links
Okay.
both sides, right?
Okay.
So in case in switch we are having one port is in one VLAN and another port is another VLAN.
Okay.
So in that case, how it will work blocking? Because those two are two separate segment, right?
See, when you have two different VLANs, then STP also work on a different way, right? So let's say you have VLAN 10 and you have VLAN 20. Now STP for this is different and STP for this is different. So STP works on per VLAN basis. So the VLAN 10 will have its own STP calculation, VLAN 20 will have its own STP calculation. So in the case of this, I was pre-assuming that they are running on VLAN 1, which is same VLAN. Now the broadcast can form a circular loop. When in this case, there is no circular loop because they are in different broadcasts. This is a different broadcast. If something goes in this, there is no way that it will come back in this because this is a different broadcast, right? STP works on per VLAN basis. This is the main thing that you have to remember. STP on 1 is different, STP on 10 is different, STP on 20 is different. And accordingly, we can change the behavior. Let's say I have 4 switches. I have 10, 20, 30. 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 Now, I would like to make switch A to be root bridge or the primary route for VLAN 10. Similar way, I would like to make root bridge 20 for 20 as this switch. So it is a per VLAN configuration. Manipulation can be done per VLAN basis. So that is why do you remember the commands like when I was playing around with the tuning, I was mentioning about the VLAN ID. So if you see this closely, the commands to manipulate the priority deals with the VLAN ID. I took it as 1. Now in your case for 10, I would have taken it as 10. Similar way for 20, I would have taken as 20. So the commands goes well with VLANs. Okay, the more VLANs you have, the more tuning you can do on individual VLAN basis. So is that your question?
Yeah, and one more,
Okay.
where we use the setting simplex.
Simplex is very older technology. I don't even know any anything in production that is still using simplex mode. Okay. The best example for half duplex was those walkie talkie, if you remember, where one person used to send some hello message and then after that the second person used to respond back. This is something which I can remember, but for simplex I have to Google. If someone knows, please tell it, you can share your experience about the simplex mode of communication. Okay, this is very older technology which I doubt we are even using it in the network. Okay, cool. Fine. So let's start with the lab. I have all the devices powered on. By default, the standard CLI command is show spanning tree, and I'm on device number 1 and I don't see any root bridge. Okay, so I assume this switch number 6 will act as a root bridge because of the lowest bridge ID. Okay, so that is not the switch. I think it's switch 5. Okay, so the switch 5 has taken and won the election. It has declared himself as a root bridge. All the ports are designated port. As we all know, the root bridge Okay, root bridge will have its all port on a designated forwarding. So that is what you can see, designated with the forwarding feature. Rest, now they will start making their way to reach root bridge. Okay, now first thing first, I will change STP to RSTP. So this is very simple command, but while doing this, I also have to see what are the negotiation happening. For that, I will open up Wireshark and I will show you the concept of proposal and agreement. Okay, so this is the first lab that we will do it now. So let's open up the Wireshark here. Let's filter it out for only STP. And as of now, you can see they are running on the legacy STP packets. Okay, all the legacy, the configuration, BPDUs, all those things. Now let's change the behavior. So what is the command to change it? Okay, so the command is straightforward. It's only spanning tree mode rapid STP. So let's take the console of every devices. Let me go to conf t and let me paste this. Okay, so this command I am going to place across on the boxes. That's easy way to do the changes. Okay, if you have it on notepad, just copy it and keep applying it on all the switches. Okay, it's faster way to do that. Switch 3, switch 4, switch 5 should be with me here. I'll just change it. Switch 6 is with me. Switch 7. And the last one, switch 8. Okay, so they are all running on RSTP. Now a quick interview question: what if I would have left one of the device on the legacy STP only? Let's say I have some devices on STP only and some I just change it to RSTP. Will they stop working? Will they work? What is the behavior? What is the negotiation? Okay, so basically they are backward compatibility. Okay, your RSTP will work on the topology where you even have the legacy STP. The only thing is, let's say when you have a switch with RSTP will send the proposal. But your STP will not understand what is the meaning of proposal, because STP works on BPDU, and under BPDU you will have the configuration type of BPDU. It will go under the 50-second of timer. So what happens is your legacy STP will still follow the same pattern of 50-second. It will negotiate and it will start forwarding. It is still backward compatible. Okay, so it doesn't mean that if you have some RSTP, some running on the legacy STP, it will not work, or there will be some glitch, there will be some inconsistency. It's not that way. It will still work. STP will still take its own 50-second, and your RSTP will still start sending the proposals only. Okay, but still they will work together. It's not something they will break or something. They will still work together. Okay, now I have RSTP on all the devices. I want to show you how RSTP works. Okay, so these are all these are STPs. Okay, so these are STPs. So initially they were taking up, so let me stop that. So initially they were taking up all the legacy negotiation. If you see this, you can see the configuration BPDU, which is a part of legacy STP. Now let's see what happens when you change it to RSTP. Okay, rapid spanning tree protocol. So let's see what happened over when you changed it. So you could see some topology change notification because you changed the mode. So this is spanning tree, spanning tree, spanning tree protocol. Okay, it's over here in the 87 and 88 packet number. This is called packet number. Okay, I'll just write it here. Packet number. So if you see the packet number 87 and 88, 87 was on your STP and 88 packet was for your RSTP. Okay, so that is where the things will get changed. So if you see this, 87 packet number is spanning tree, and similar way your 88 packet number okay, sorry, that is 89 packet number, where you can see the rapid spanning tree effective. Okay, now let's see from RSTP point of view. From 89 packet number, they are all RSTP packets, and you can see still some spanning tree protocol because we were in a phase of migrating the other switches one by one, so it was still going on. Okay, so from RSTP point of view, we can see from forwarding learning topology change. There is nowhere we can see something for blocking state or a listening state, because I told you RSTP don't follow this. This will be coming under your disabled mode. Okay, and from disable it will go to learning phase, and from learning phase it will go to the forwarding phases. So that is how RSTP work. And second thing that I want to show you is the protocol, the negotiation, the proposal and the agreement. Okay, so this is a proposal. This is a packet for a proposal. So when I have two switches, when they form the initial negotiation, they will share their bridge IDs. Okay, so switch A will send its bridge ID and switch B will send its own bridge ID. Now this is a part of the proposal. So one has to agree for that. So it will send the agreement packet. Okay, so let's see this on devices also. Okay, so let's say this is my device. So which is the root bridge here? As of now, the root bridge is my switch number 5. So this is my root bridge. Okay, I'm going to enable the spanning tree protocols here, or I'm enabling the debugs here, debug spanning tree events. And let's say I just go and shut few of the interface. So let's say I'm going to shut from range 0/0 to 3 and also 1/0. Okay, I'll just shut down, and also I'll make it no shut. So we can see the RSTP negotiation. In my last class, we saw the negotiation happening in the inner states, like blocking to listening, listening to learning, learning to forwarding. But here we will not see such kind of state. It will be direct, straightforward proposals. Okay, we are transmitting the proposal. Okay, I'm seeing, I can see that I'm starting up the proposal to every interface. I'm sending my bridge ID, and I will take up the root bridge preference also, because my bridge ID is more superior than all my neighboring switch bridge IDs. Okay, So this is what happens. This is a drastic change in a rapid spanning tree. And if you observe, it didn't even take uh, uh, it didn't take 50 seconds for your ports to reconverge. It was just 1 second. Okay, so let me just show you once again what I'm trying to say. Let me go to conf t. If I go and disable all my switch port, so it's equivalent to bringing this switch out of the network. Okay, so this should not be a root bridge as of now. We can see that which one becomes a root bridge. Okay, this is not the root bridge. Okay, the last one can be the root bridge. Okay, so the last one has taken up the role. So from this device, as soon as I brought all the interface down, this one elected itself as a root bridge for now. Now let's bring back our original device. Okay, so I'm going to make it no shut. So once I make it no shut, let's see whether it lost its, see, it has already lost. It has lost its designation of root. Did it take 50 seconds? No, it was within a 1 second, right? It lost its eligibility. Okay, and let's see from this switch point of view, show spanning tree. It's a root once again, and we can see they are in a directly in a learning phase, and it will go to the forwarding state in one second. So this is what is a plus point. See, it's all forwarding now. Within 1 second, reconvergence happened. It took back the role, which in a normal STP, it was supposed to take 50 seconds for all the states, all the events, all those things. Okay, fine. So this was regards to the RSTP and STP. Now let me show you the tuning part. Okay, so that for tuning part, I need these things. Okay, especially these things. Okay, before that, I want to show you alternative port and the backbone port. Okay, so for that, I have one hub. I have just recreated the scenario where I have a layer 2 switch, a managed switch connected with unmanaged switch. Okay, so in this scenario, if I zoom in, so when I have two links, we can see one will be backup port in a blocking state. Okay, so I'll go to switch number 8. Okay, looks like this is not the one. Okay, I'll click on this and open up. Okay, I don't see this because, okay, so where is this? This is designated and this is also designated.
Hi, Saga.
Yes.
Sorry, could you rename those switches to switch 1, 2, 3, 4, 5 so that we can know which one you are working on?
Yeah. Actually, I had done that, but once I reset everything, even the host names are taken down. So I'll do it. Okay. So I'll connect two different links on this hub, and from this hub I am going to take connection to the computers. So this was something which we discussed in the RSTP, and now let's see the behavior. Okay, now this is the one which I was trying to see. This is the plus point of your RSTP. Now, though it's in blocking, it goes into the backup port fast scenarios. Okay, so if I go back to the document under RSTP, this feature, the backbone fast feature, when we see this, especially during the hub scenario. Okay, so it has put it into the backup port. Now let's say the forwarding link goes down for some reason. It will not take 50 seconds, it will just take 1 second to transit and start forwarding. Okay, so this is one of the additional terminology in RSTP. Similar to this, let me show you alternative port or the alternate port. So this is the alternative blocking port. So this is also in blocking nature, but it is temporarily put into that. As soon as the actual link going towards root bridge fails, this will get into the root forwarding or the root port nature. So these are the two things, two additional things which the legacy STP don't have it. Okay, fine. Now let's talk about the port fast things. Okay, so let me talk about the STP features. So what is port fast and where do we enable that? So this is a feature which we specially activate on these interfaces, the interfaces which connects with the non-BPDU devices. Okay, so these are considered to be non-BPDU devices. So why do we make use of port fast? The port fast, what is it going to do is, it is going to remove those additional states from this side. Okay, they are not going to take your disabled or listening state. Okay, disabled blocking listening state. It will directly put from learning to forwarding state. So there is as good as no STP running in this, but only chances are when someone by mistakenly remove this and connect a another switch, another non-BPDU, another BPDU. Now there can be looping. Also, second thing is, if someone is connecting a computer over this and he introduced some superior BPDU here, the all root bridge will get transited to this switches. Okay, so to avoid that, we have to make use of other features along with port fast features like BPDUGaurd, filter, and all those things. So let me first show with port fast what is the command for port fast. So if you want, I can also enable these things. For that, first I'll keep some IP address. Okay, so let's say I'm giving an IP address on some easy node 192.168, let's say 99.1, 99.100. You just power them on. Similar way, go to edit. So let's keep it as 99.2 and this is 99.100. And over on this switch, let's go to global configuration. Let me give an IP address to that VLAN 99. Let's say this is on IP address 192.168.99.100. 255.255.255.0 and no shutdown. Similar way, I'll go to these switch ports, especially these two switch port, this one and this one, and I'll assign VLAN 99. Because they are working on VLAN 99, I have made use of interface VLAN 99. So that is the reason I'm also going and making it as VLAN 99 there. So let's go to interface Giga Ethernet 0/0, I'll say switch port mode access, switch port access VLAN 99, no shut, and I'll go to the next interface 0/3. I'll make it switch port access, switch port mode access, switch port access VLAN 99. Okay, so let me give a try by pinging from one device to another device. So let me make this up. So what is the IP that I configured here was 192.168.99.2. And same thing, I configured this on 99.1, and that is running on 99.100. Okay, so let's ping the second IP. So first let me check what is the IP address of this. So it's on 99.1. Now let me ping the second device, that is on 2. It is running fine. Okay, and if I see from the MAC address table point of view on this device, show MAC address. Okay, so I can see plenty of them, but I need to concentrate on the 99 VLAN 99. Okay, because all my other RSTP are running on VLAN 1, but these two computers are connected on VLAN 99. So this computer is binded on this interface. So the MAC address of this, okay, so let's say the MAC address is 3274. So let's say the MAC address is 3274 here, and the MAC address 88F3 is on this. Now this get associated with this interface. So that is your MAC address table. Okay. So if you see this is the physical interface 0/0, and what is getting associated? The MAC address. Okay. So this is a binding. Similar way, you can see the binding between this interface and this computer, and on which VLAN? That is on VLAN 99. Okay. Now if I ping from one device to another device, it's reachable. Now what I need here? So let's say I disable one of the interface. Okay, I go to configuration T, I'll go to 0/0. Okay, let me also bring debugs here. Okay, I have enabled the debugs. Now let me shut this. So once I shut it out, this will lose the ping reachability. Now it's no longer able to send any ping reachability. The reason is the packet which you are sending from this machine to here, this has been shut down, or it's down now. Okay, this is down now. So your switch will not process it further. So this is equivalent as not reachable. This cannot be reached. Okay. Now my intention is to unshut that. Okay, I'll make no shutdown. So when I do no shutdown, what I can see is RSTP has been configured. Okay, so it should be pretty much faster. So 0/0. So it's taking some time. We can also see in this way. The straight forward command would be show spanning tree interface 0/0. Okay, and it started forwarding. So my question is, why do we need spanning tree between this? Can't we remove the spanning tree process between this? Because this calculation, this reconvergence is hitting on my switch CPU or the memory of the CPU, right? So how if I remove the STP concept from this? Okay, STP or RSTP, I just want to remove out of these, because there is no BPDU here. So there is no point that there will be loop happening here. So I can just remove that. So what is the command? I'll introduce the port fast features here. So what I'll do is I'll go to that interface on interface GI 0/0, and I will make sure that they run on port fast. Okay, the command is spanning tree port fast. So I get a warning message saying that don't enable this particular thing on inter switches. The warning says port fast should not be enabled on ports connected to, should be enabled only on ports connected to single host. Okay, connecting to hub switches bridges can cause bridging loops. So in my case, I am safe because I am connecting to a computer. So that's a non-BPDU. And similar way on my second interface, that is GI0/3, I'll enable spanning tree port fast feature. Okay. Now they both are running on port fast. These two are running on port fast. So let's see. Okay. So now they are pingable once again. Now from point of reconverging. Okay. So let's go to GI0, 0. Let me shut this. This will stop. This got stopped. Okay. No further communication happening because I have shut it down. And let me bring it up. So I bring it up. Okay. So once I bring it up, you can see they start working. Right. So how much time did it take? It didn't take 50 seconds now because port fast went directly to the forwarding state. Okay. So let's see from the debugs what exactly happened. So from the debug state, we can see that RSTP directly pushed it to the designated port. So that is a benefit of port fast having on the edge devices. Otherwise, let's say you have users, you are doing the testing and every time you are waiting 50 seconds for the port to go into the transition period. Okay. So that is the reason we bring port fast. And remember, this port fast has to be enabled only on the edge devices. Okay. Don't enable between the switches. Now, what is the, so we are good with port fast. Now, regarding to the measures that we have to take, that is, let's say someone by mistakenly connects a switch here. Let's say I drag one of the switch from here. Okay. One of my field engineer by mistakenly he disconnect this and connects a switch to this switch. Now both are BPDU sending devices, and now that's an issue because your port fast has disabled STP. Okay, your port fast is not going through those initial states of root bridge, root port, all those things blocking. Everything is forwarding. Okay, now this can cause an issue. So in order to avoid these things, what we do is, along with the port fast, we also enable other features like BPDUGaurd or BPDUFilter. Okay, now let's start with BPDUGaurd first. Let me tell you what is BPDUGaurd. So before that, I will disable this first and I'll bring back the original line. Okay, so it will take some time for it to negotiate. Okay, so let's see if they are reachable now. Yes, they are reachable now. And do I have the port fast features here? Okay, so as of now it's connected to 0/0. So this is important. Okay, just by mistakenly don't bring some other interface down. So always keep the labels on your screen so that it's easier for you to tune. So over on 0/0, this is some other configuration. Let's see what is 0/3. Okay, fine. So I have both on 99 and I have the port fast connected. Okay. Now what I'll do is, on this particular interface, I'll enable something called BPDUGaurd. So let's go to interface 0/0. Let's say spanning tree BPDUGaurd enable. Okay, and how do we make confirm that we have done the right configuration or not? It's show spanning interface 0/0. Sorry, not this command. Show spanning interface. Okay, I can do show interface 0/0. So when I do this, Okay, I think there is one more command here, show spanning tree interface 0/0. Okay, so anyway, so there is one command where we can see if BPDUGaurd is enabled. Okay, so now how do we check the behavior? How do we check the behavior? What happens? So from PC1 to PC2, it's still running. Now let's say I have taken down this by mistakenly, as I told you, and someone connects a computer. Okay, so computer on the switch port 0/0, and he has powered it on. So now what happens is, let this device come up. Okay, let this device come up. Now they both are BPDU sending devices. So the second device is coming up, and let's see what is going to happen. Show IP int brief. So you can see it's put up on a down state. Okay, and if you see the behavior of that switch port, it has gone to error disabled mode. Agree? So why did it go to error disabled mode? Because you have configured that add-on feature called BPDUGaurd. If there was no BPDUGaurd, if it was only port fast, this would have been a functional port. They both would have been forwarding. Now there was chances that this switch has a better BPDU, and this one become the new root bridge. And now someone who is connected to this switch can play around with the network topology. He can make the changes. He can bring some impact on the network. Okay, so in order to avoid such reasons, I enable BPDUGaurd, and there are two ways to configure BPDUGaurd. One is globally, second one is over on interface. So right now I did on interface. Okay, globally and interface has the same impact for BPDUGaurd. It will put them under error disabled mode. How do we check the error or inconsistency port? I can put the command show error disable detect. Okay, so when I do this, I can see that when I have BPDU as one of the factor, okay, BPDUGaurd as one of the factor, they will directly detect and they will put under error disable. That is why my switch port went into error disabled mode. Okay, and we also have something called recovery process. If you see this recovery process, what happens is, let's say then we realize our mistake, I take it down and I'll go back and connect with my computer. Now this will be doing the automatic polling if this has been taken down or it's still sending BPD. Now it will detect for whatever time that we set here. Let's say for 30 seconds I set it. So for 30 seconds, if there is no BPD received, it will disconnect this and it will say that this particular switch has been removed. Now I'm okay, and the port will put back to the up and up status. Okay, so let me show you what is happening. What do you mean by that? So as of now, there is no error disabled recovery. They are all disabled, but yes, I can enable them by error disable recovery interval. Let's give 30 seconds, and what cause? So let's say for cause of BPDUGaurd. Okay, so it will poll for 30 seconds. It will see that if there is no BPDU, let me put back to the normal behavior. So now if you see this, it's still under error disable. Okay, now let's say I realize my mistake, I delete this, I'll put back the interface on a right device. Okay, so after 30 seconds, I am expected to see the auto recovery. Okay, so this is what we get. Now it has put back on the up. So there was no human intervention, right? There was no involvement of any network engineers. So if you see the status, now they are back to connected. Okay, and what is the message that was given to us? attempting to recover from BPDUGaurd. So after 30 seconds, it was automatically put back. And yes, the BPDUGaurd can be configured on a global way as well as on interface way. They are the same impact. They are going to put under inconsistent mode. Okay. Now this is one method. Now the second method is called BPDUFilter, and this is little bit confusing. Okay. BPDUFilter can also be configured on a global way as well as on a interface way. Now let's say you have enabled on a global way. So once you have enabled on a global way, it will, let's say I have a switch, I had a computer, someone removes this off and connects a computer. Now it send the BPDU, and this port is able to recognize or read some BPDU coming in, where we have said that there shouldn't be any BPDU. We started receiving some BPDU. Now let's say you configured the BPDU filter on global. So this will remove the port fast behavior immediately. And second thing, it will remove the port fast behavior immediately. Okay, so this is one thing. As soon as BPDU is received, the port fast feature will be disabled and it will be the normal port running on whatever STP you are having. Second thing, on a interface level, let's say you went and configured on a interface basis, let's say interface, and then you configured BPDUFilter command. Now what happens here is, as soon as you receive something, the interface will stop working. Okay, the port fast feature will be still present, it will be still port fast, but interface will stop. Okay, it will stop receiving and sending any BPDUs to anyone else. So due to this, what happens is this switch will not send anything to anyone else. So these are the add-on features to save our topology or our network. Otherwise, what happens, there is chances that this is a superior switch and all the reconverges happen and this becomes the new root bridge, which I don't want. Okay. Okay, now let's do this configuration. So what I'll do is I'll remove the BPDUGaurd from my 0/0. I'll go to configuration T. I'll say no spanning tree, or the command is straightforward disable. Okay, don't have to make use of no spanning tree BPDU. Okay, first go to interface 0/0 spanning tree BPDUGaurd and disable this. Now you have to enable BPDUFilter. So you can first I'm showing you the interface behavior, then I'll show you the global behavior. So when I'm showing you the interface behavior, just enable this. Okay. Let's verify the configuration of this interface. So this is having BPDUFilter and it is having port fast. Okay. Now let's see what happens when you by mistakenly take this connectivity to the switch on 0/0. So once you do that, we should be seeing some disturbance over on the switch. Okay, so what is that disturbance? Show interface GI 0/0. Okay. So let's see if BPDUFilter is enabled or not. Show interface GI 0/0. Okay, so this device don't have a command called details. Okay, so under details we can see that BPDUFilter details.
Okay, Sagar, try switchboard.
Okay. So anything that we see here?
No, I don't see it.
Yeah. So basically there is a command called detail for some of the iOS family. If I get that equivalent command, we can see the BPDUGaurd, or we have to see the running configuration to make sure if it's present or not. Okay. So from there I can see BPDUFilter is enabled. Okay, show interface GI 0/0. No. Okay, let me see counters. I want to show the BPDUFilter behavior. Okay, so I need to see some statistic of that interface. So that will help me to show you. Stats.
I think interface summary, I think.
Do we have summary? I think we tried that, right? Okay, let's give it a try. Okay, not here. So basically I want to see the BPDU packets. Okay, I think this one should show us. Okay, so what is that command? It's accounting. So when I have accounting, so we can see that as soon as we have enabled BPDUFilter, we don't see any increment on a outgoing BPDUs, right? The incoming BPDUs are from this device. So this box is sending incoming, or this is sending some BPDUs to this switch, but this switch is not sending any further BPDUs because we have enabled BPDUFilter. The meaning of BPDUFilter is to stop sending the BPDUs. Okay, so that is what I'm trying to see, and yes, it's not increasing. Okay, these are not increasing.
Show spanning tree detail.
Okay. Show spanning, I think I remember the command. It shows spanning tree interface GI 0/0 and details. Okay, so when I have this, it says BPDUFilter is enabled. You can see that there is no packets enabled, or there is no packet received at this moment. Okay, because of the BPDUFilter enabled. What BPDUFilter does is it will stop the packets. Okay, it is not going to send or receive. So that is the behavior of BPDUFilter, and if you do it on an interface level, the interface should go down, but I am not able to see that interface going down. Okay. So anyway, so we will move on to the next one, that is on a global way. So what I'll do is I'll enable this on the global configuration, spanning tree BPDU. Okay, for this, okay, let me go to interface first. Let's say spanning tree port fast. So do I have BPDUGaurd? Okay, looks like this is a different iOS family where the commands are not straightforward. So I have spanning tree BPDUFilter. So I can enable from here. The same command will also can be enabled from the global view. So let's say I have spanning tree port fast. Okay, it's edge BPDUGuard. Okay, so this is the command to enable from global. And why is it important is because in BPDU in BPDU in BPDU filter, okay, we are talking about BPDU filter. So in BPDU filter, these two commands have different significance. So BPDU filter on global configuration is going to remove the port fast behavior. It's going to remove the port fast behavior. But on an interface level, it's going to stop the BPDU incoming and outgoing. Okay, there will be no incoming and outgoing on an interface. So that is what we saw when I have enabled on the interface. I was not able to say any counters increasing. It was stuck on 100 and 0. There was no increment. Now, since I have enabled on a global, so let's see if I do see any changes on the behavior. Okay, so that is fine. Do show spanning tree interface GI0/0 details. So this has been stuck. Okay, there is no BPDU receive dot send. That is the default behavior. Edge mode. Okay, I can do one thing. I can first remove from the interface so that my global start taking up. Okay, now I took it from the interface, so I should have only on the global way. Okay. Do show interface GI0/0. Okay, so this is something what I was expecting is this interface will go to outside of port fast behavior. Okay, so I was expecting this go beyond the port fast behavior. Okay, so is it taken down from the port fast? So that is what it has happened, right? It has taken down the port fast behavior. So let me once again configure port fast, spanning tree port fast. So ignore these messages. Okay, these messages are because of some duplex among the two switches. So it has nothing to do with the configurations that we are trying to do. Okay, so basically what I want to show is that this interface will go out of port fast as soon as it starts detecting some BPDUs. Okay, so that is the behavior of BPDUFilter. So let me show you the next thing or the next enhancement method, that is called as RootGuard. So RootGuard is an add-on feature where I can define my switches to be always primary devices. Okay, no matter what happens in a network topology, I want this to be always my primary and I want this to be always my secondary. Now we can set that. Okay, why I'm doing this is why I'm implicitly defining this is because see, we know that we can change the behavior with the help of priority command and also with the help of primary and secondary command. Okay, but let's say someone introduced one more switch with zero priority. Okay, even though you made use of this, it was going with 2 4 and 2 8 in our previous class calculation. Right now someone brings up a switch with 0. In that case the chances are that this will lose its root bridge behavior. Okay, so with the help of this feature I can say that whatever comes to the network, even if they have 0 and even if this has 24,000 or something, this will still be the root guards. Okay, or this will act as a root bridge. So this feature is called as a root guard behavior. So I'll go to the first box and I'll enable this. So as of now this is already okay, so this is not a root bridge at this moment. Okay, but I can make this as a root bridge. Okay, so what I'll do is I'll go to conf t, go to the interface range command 0/0 to 3 and 0/1/0. Okay, and make spanning tree guard root. It's other way around. Okay, guard root. So you can you can bounce the port and you can see the immediate effect of this. So what we can see is root guard blocking, all those things and all. So if I do show spanning, I can see this. It has taken the root privilege, right? The privilege was with some other device, but as soon as I configured root bridge, I mean when I configured root guard here, it started up as acting as root. Now let's say if I introduced some other switches, let's say this switch, I tune the priority or I tune the default behavior so that it will start sending the superior BPDU. Okay, superior BPDU in the sense, first I have to see what is the cost priority here or what is the bridge ID over here. Then what I'll do, I'll tune this and I'll start sending a better BPDU. Now let's see what happens to the interface here. Okay, so that is what I need to check here. So first I will see the priority is 32769 and priority is 32769. Now it's little easier for me to make the change. So I'll go to this this device, the device number 3, and I'll change the values. Okay, so how can I change the value? By the priority command. So I'll go to this, okay, let me change the host name so that we know what is what. Okay, so this is switch 3. I'll go to spanning tree VLAN 1 priority 4096. So once I do that, these two ports which are directly connected will send a better BPDUs. Now let's see what happens to this actually, the two interfaces there. So this is my first switch. And if I do show spanning tree, so you can see that my switch has detected a better BPDU and it started putting them under a root inconsistency method. Okay, inconsistency method, and this will be in a blocking state until we fix this issue. We have to take down the switch, or we have to take down that priority command. Okay, if not, this will be still in a blocking method. So that is what a root guard does. When you have a root guard, and in a network, if you try to bring some other switch with a better priority or better BPDUs, this switch ports will automatically be put into root guard or in a root inconsistency method. Okay. So how do we see the inconsistent port? So show spanning tree inconsistence. Okay. So over under this command, I can see all the inconsistent mode, and this inconsistent mode are in a blocking state. They are not in a forwarding state. Okay. So now let's say I take down that command. I just go back and I take down that command of this. So let's say I don't need this command. Let's shut and let's no shut down. Okay, forwarding. And what about this switch? Okay, this is a root and it's still blocking, right? So did I remove this do show spanning tree?
You need to shut on the primary switch, the ports over there.
Okay. So basically the bouncing will get it up.
Right.
Okay, so as soon as I bounce this, we can see the BPDUs are being taken care of, and they will come back off that. Okay. Or I can do one thing, I can just straight away switch this off. Okay, now you can see it started unblocking because I have turned the switch number 3. So they are coming out of that. Okay, they are coming out of that, and they will fall back to the forwarding state. So that's about the root guard. Okay, so you have one more behavior here, or one more last one. So over on this, let's take other devices as well. Okay, now they come out of that. Okay, now they will go directly to the forwarding. Okay, so meanwhile, let me just quickly tell you the last one so that we can wind up. So the last one is called as LoopGuard. So this is a looping caused especially in a optic media or a optic fiber media. Okay, the reason is when we have two switches which are connected over on a Ethernet cables, they have two pairs for receiving the data and two pairs for transmitting some data. Okay, so if we talk about a Ethernet medium, they comes with 8 pairs of color. So out of 8 pairs, 8 colors, 4 pairs of color, but 8 individual links. So you have 2 different cables responsible for receiving and 2 different colors responsible for transmitting. Okay, so two different colors for receiving and 2 different colors for transmitting. In case of optical fibers, you just have one media for receiving and one media for transmitting. Now the issue over here is, let's say if the Tx goes down, for some reason Tx is down. Now what happens is your both the switches declare them as root bridge. Okay, so in this case what happens is, even if one thing goes down, you still have the connectivity. There is still Rx and the other Tx going on, so they know that there is a separate root bridge and it is taking care of everything. But in case of optical fibers, we don't see that. Okay, we only have one single channel for Rx and one single channel for Tx, and if something goes down, then it's only Rx which is sending something. Okay, in this case we call it as unidirectional looping. Okay, unidirectional in the sense single direction communication. So this is called as unidirectional looping. So what is the command to check this, or what is the way we can avoid this? So what I'll do is, I'll just take two switches. I'll bring all of them down. So let's say I'm talking about these two switches. So let's say I have these two switches. So let's see which one takes up the root bridge now. Okay, so let me do show spanning tree. So this is of course not a root bridge. So I believe the switch 8 is acting as a root bridge. Okay, so one is root bridge and other one is non-root bridge, and we have all the necessary calculations. Now how do we enable, or how do we make sure that we don't encounter any unidirectional looping? So the simple command is, on a non-root. Okay, so the previous command which was about configuring RootGuard, I went straight to the root bridge switch and I configured this behavior. Now when I'm talking about LoopGuard, I don't have, I am not supposed to configure it on a root bridge. Okay, I am supposed to configure on a non-root bridge switches. So that is how the command is effective. The reason is, let's say I have one switch connecting to another switch. Now this is already a loop bridge. It's a already a root bridge. Now what is the point you configure the unidirectional behavior here, right? Because what is the expected behavior? Expected behavior is this will also become root bridge and this will also become root bridge. When you have the unidirectional issues, this switch will not receive any superior BPDUs and this will start declaring himself as a root bridge. So in order to avoid such things, you have to configure LoopGuard on a non-root bridge switches, not this. Okay, your previous feature, that is RootGuard, that was meant for root bridge switches, but at this moment we are dealing with LoopGuard. This is a different feature, and this to be enabled on a non-root bridge. This is something which you have to remember when you're making use of this feature. Okay, so this is a non-root bridge. I just checked the spanning tree output, so it's a non-root. Okay, I'll go to the config T. Let me go to the interface. It's 1/0. Let me enable guard loop. Okay, so once I enable this, let's see the command show spanning tree interface gi0/ okay 1/0 details. Okay, it says LoopGuard is enabled. Okay, now how do I check the behavior of this? Okay, so to check the behavior of something, I have to reproduce the scenario. So let's make this as a BPDU filter. If I make this device as BPDU filter, then this will stop sending and stop receiving. So that is equivalent as your unidirectional errors, right? So what is your unidirectional error? When you stop receiving the BPDUs. Now when I make this switch as a BPDU filter, the behavior says don't send any BPDUs to the other switches. So now once it doesn't receive anything, it will declare himself as a root bridge. Okay. So I'll go straight to the switch 8 and I'll configure it to be BPDU filter. Okay, so let's say this is interface GI01. Okay, at this moment, let's see the BPDU counts. So they keep on increasing, right? They are sending the BPDUs. They're sending the BPDU. So now let's enable the BPDU filter. So let's say spanning tree BPDU filter enable, and we should be seeing this becoming a root bridge. Okay, so now you can see that LoopGuard blocking enabled, and we became the root bridge. This is something happening in a case of unidirectional errors. Okay, so when I do this switch himself declared him to be a root bridge, and we also have one more device which is a root bridge. Okay, so this is a case of unidirectional error, and it happens especially in a fabric condition, in a fabric medium where we have one medium for RX and another for TX, whereas in Ethernet we will have two cables for RX and two cables for TX. Okay, so let's see what happens to this. So show spanning tree. So what it has done is it has blocked it. Okay, it has blocked with a comment saying loop found. So this is an expected behavior on a LoopGuard. So in order to avoid any unidirectional loop, we enable this LoopGuard. As soon as it starts detecting, as soon as it will see that there is some BPDU loss or something, it will put that interface on a root blocking state. Okay, so it is put on a root blocking state. So let's say if I start or I remove that behavior of a filter, spanning tree BPDU filter disable. So let's see if this comes back. Yeah, it has unlocked himself. Okay, so this is a mechanism to save any unidirectional issues. Okay, so let's quickly see spanning tree. So the root bridge has gone back. Okay, and the port is not a blocking anymore. Okay, sorry, the port was this, which is not blocking anymore. It's a root forwarding. Okay, so we discussed all the types of tuning for an STP port fast. So it's not always bringing port fast, it's also taking care of all other things that can happen in your topology. Okay, there can be RootGuard issue, there can be unidirectional issue, there can be someone by mistakenly take down the cable from the PC and connect to the switch. Now that can also cause the issue. So these all things that we learned today are to avoid such port fast issues. Okay, and where do we use port fast? Is basically between a Cisco switch and a non BPDU devices. Okay, so in this scenario we don't need any spanning tree. So we can enable the port fast feature, and along with port fast feature, you can enable the other things like BPDUGaurd, BPDUFilter, and all other things. So it depends again on network design. Some company go with only BPDUGuards, some company go with BPDUFilter. Okay, so it depends on how complexity you are able to resolve the issue, because if during some such scenarios, the BPDU filter can completely bring down your network. Okay, now to troubleshoot that and fix the issue will take a lot of time. In case of BPDU card, you will be seeing the port under inconsistent mode. You can set some timers and it will automatically be recovered also. Okay, so it depends on design to design, which features you want to enable. There is no straightforward, or there is no written practice that you need to have everything. Some make use of one or two features, some don't make use of, because they might have a different solution for that. Okay, so yeah, that's for today's class. I think I have taken a lot of time today. Okay, so if you guys have any doubt, please let me know. So basically, these spanning tree protocols are little complex, so you have to like practice and you have to do a lab to understand. Okay, so any doubt as of now? Okay, so I take it as no, and okay, I see there are a lot of chat. So okay, so let me quickly see this. In what instance do we have half and full duplex? Okay, so basically this half and full duplex is seen on a model version. If you have a pretty older version, you will see the devices used to be in half duplex, especially your hub and unmanaged devices, they come in a half duplex. Whereas your manageable switches, they by default come by full duplex, and you don't have to worry about that. Now there are some servers, servers still which works only on half duplex. So in that scenario, even though my switch port supports full duplex, I have to make it half duplex. Okay, so that I don't get continuous log saying the mismatch in half and full. Okay, I think this we covered 2-3 times, so you can go back to the recording and you can see this. Okay, why hub is introduced in between a switch. So basically, I'm not sure. You have to contact me back, because I don't know what is your real name. Okay, so better make use of your real name. So those guys who have already enrolled, they have the direct access to the portal. So I'm not sure why you are asking the Google Drive at this moment. So I also I don't know your real name. So after the class, ping me on one-to-one basis, and then I'll let you know where to get all the PDF, all those things. Okay. What is alt port and what is backup port? Already answered. So you guys can download the PDF of copy as well. So whatever is put up on the online web pages, that can be downloaded as a PDF. Okay, I have set the option to download as PDF. So if you click on that, it will take you to the slide share, and from there you can download. I have seen some guys have already downloaded that. MSTP will cover that topic using older legacy. Okay, what is the length? 60 for notification. So are you referring to the STP states of each thing, which takes 50 seconds? Okay, so again, I'm not sure whether this was answered to one of the question above. Yes, this is the command to save the configuration. Okay, and in GNS this is not effective. It's always run copy startup. Okay, run copy startup, which will save the configurations. Okay, regarding the BPDUGuard and BPDU filters. So it's basically the difference how they work. Okay, so let's say BPDUGuard, and on other side I have filter. The first difference is BPDUGuard runs or works on a similar behavior on a interface and a global way. Okay, what is the behavior? It will put under inconsistency mode. Your switch port will be inconsistency mode. You can put, or you can have some recovery, auto recovery enabled, and as soon as the BPDU gets removed, the port will automatically be start in a forwarding nature. But in a BPDU filter, the behavior is different on an interface level and also on a global level. On a global level, as soon as the switch receive any BPDU, it will remove the port fast behavior. That is first thing that is going to happen on a global. And on a interface, it's going to put on a shutdown. Now, inconsistency is a different thing, and a shutdown is a different thing. Okay, shutdown is when your interface is completely shut down. Okay, whereas inconsistency is something when interface is up. Okay, if you see the show interface, it will still show up and up, but along with just next to that, you will see something as error disabled. So this behavior is different and this behavior is different. So these are two different things, and as I told you, depends on the network design. Some network design go with BPDUGuard because troubleshooting and fixing is easier. Some straight away go with BPDUFilter because here inconsistency, if you don't set auto recovery, then they will be in inconsistency mode, okay, forever. So you need to shut and unshut. So it has its own plus and minus. Okay, so is it fine? Don't you see my screen? Are you not able to see my screen?
Hey Sagar, when you open your chat window, it's like black, everything is black.
Okay, so when I asked last class, so guys told that they are able to see the chat window. Is it something that I have to?
Last class we were able to see. This class we can't see.
Okay, is there something to deal with the settings? Anyone aware of something?
No, I don't think it's setting because it just started about 15 minutes ago.
Okay, okay. Okay, some weird thing. Not an issue. On the recordings, we can see the things. Okay, might be Zoom has some things inbuilt. Might be because of that it disabled. Okay, anyway. So any doubt here, guys? Are we good? Are we good with the class today? Is it something which was not clear or something? So are we good so far?
From myself, I'm fine.
Okay. Okay, guys. So see you in the next class, and take care till then. Have a nice day. Bye.